I'm back with a new topic from mathematics, first order differential equations in growth and decay. And we'll now just explore the fundamentals of the first order differential equations and their applications in modeling, growth and decay process, which is in engineering. So myself Komal Darshan, and now let's get started with the first order differential equations with respect to the growth and decay and applications. First, the key concept which is essential for engineering students are understanding the order of differential equations and applying the which are the applications in growth models, applications in decay models, and relevance to engineering mathematics, and lastly real world examples. First and foremost thing is understanding the first order differential equations. These equations describe the relationship between a functional and its first derivative, crucial in modeling various phenomena. The second thing is applications in growth models. First order differential equations can model exponential growth applicable in fields like biology and finance. And third one is the application in decay models. These equations are essential for understanding decay processes such as radioactive decay and population decline. And the relevance to the engineering mathematics, the applying of the knowledge of these equations is vital for computer science and engineering students for solving the real world problems. And the last one, which is real world examples, which includes population dynamics, investment growth, and the cooling loss, showcasing the practical use of these equations. These are the major applications which differential equations are dealt with. And moving on to the third slide, understanding the differential equations. As we saw the applications of the differential equation where it can be used, now we'll know the definition of the differential equation. A differential equation is a equation which involves the functions and derivative, illustrating how quantities can change. Same as well the nature of change and the real world examples and the importance in engineering and the differential role in physics and the biological modeling. And now quickly go into the fourth slide, which is about the definition, general characteristics, and the common forms. As we all know that the differential equation is expressed in the dy by dx is equals to f of x comma y, and the characters are this equation only involves in the first derivative of the function, indicating direct relationship. And the common forms. First order differential equation includes various types such as linear equations and variable equations. And moving on, understanding growth. Already we discussed that dy by dt which is equals to ky, and understanding the decay, which is a negative form of dy by dt, and the mathematical modeling and application in population dynamics and application in radioactivity, and then a financial models. And now let's get understood for growth and decay. Understanding exponential growth. Exponential growth is represented by y of t, which is equals to y minus 0 and e raised to the power kt, indicating a rapid increasing over time. And the second thing is understanding the exponential decay. Third one is initial quantity in models, role of constant k, real world applications examples. These are the mathematical modes for the growth and decay of the differential equation which we are dealing with the first order. And now moving further, real world application of modeling, key areas impacted by modeling techniques, engineering applications. biological modeling and decision making significance, as well as economic modeling. Engineering applications, modeling heat transfer and chemical reactions in crucial in engineering for designing. And the biological modeling, in biology, modeling aids in studying population dynamics and the spread of increase, improving public health strategies. Third, decision making significance. These are models are vital for the decision making process, informing prediction and the strategic planning across fields. Economic modeling, differential equations plays a vital role in economic modeling, which utilizes a modeling to forecast interest rates and inflation, aiding policymakers in economic planning. These are the real world application where differential equation used the two first order differential equation with respect to growth and decay. As we all saw that the differential equations are real world examples, and just will brief how a differential equation can be solved. Here is the stepwise analysis which can be solved. First and foremost thing, first step is to understand the equation where the given form will be dy by dt, which is equals to uh, something equation. So let's take an example with a with a given equation. Let's say dy by dt is equals to 0.1y, which is indicating a relation between y and time, something equation y and time. And the second step, sorry, and the first step we need to do is we need to separate the separate the equation with respect to the variables, which is here dy 1 by y into dy, which is equals to the 0.1 into dt, and integrating on both sides we'll get ln y, which is equals to 0.1 t plus c, where the c is a constant of integration, and solving for y, which leads to the results, which is the growth rate of 0 point growth rate. The solution represents the exponential growth with respect to growth rate of 0.1. This is how we will solve the differential equation, first order differential equation, step by step. And moving forward, yes, as we saw the steps for the differential equation which can be solved, and let's see the fundamentals of differential equations, understanding the role of differential equation. Before that, let's see the graphical representation of a exponential function, which is done by the differential order of differential equations. This is some example how a graph look like, and we'll see the next, which are fundamentals of a differential equation. First and foremost thing, the importance of first order differential equations are, these equations are crucial in modeling, as we are talked about it, which is applicable in real world phenomena like population growth and radioactive decay, which is seen first only, and the mathematical formulation and the graphical representation, which is seen now. And